Welcome to Lesson 5-2, Medians and Altitudes of Triangles. You will need a compass and a ruler to complete this lesson. We are going to be drawing a median. A median, you may think middle. Yes, it is the middle of a triangle's side. So if I'm drawing median AM, it is going to come from vertex A down somewhere alongside CB to cut it in half. Okay? It may or may not cut the angle in half. It is not an angle bisector. To draw a median, what you will need is to take your compass, place the end on vertex C, and with your pencil, you are going to choose one of your holes. It doesn't matter which one, but keep in mind whichever one you use. You're going to swing it to make an arc, just like that. You're going to take your compass and put it also on vertex B, keeping the same hole. You're going to take your pencil and swing it around so that you get this shape where they meet. Okay? Next, you could see that these line up. So we're going to take our pencil and our ruler and connect the intersection of our arcs. I'm going to do it very lightly because that's not the median. That just shows the bisector. Remember, this is a perpendicular bisector. So here's the midpoint M of CB. Now to draw a median, I need to connect vertex A with my midpoint. This right here, that's my median. It goes from my vertex to the middle of the side opposite the angle. Now for an altitude is the same thing as the height of a triangle. So remember, we're talking about straight up and down, just like you measure your height straight up and down. You don't slant. And we're going to measure from angle B straight down. It will be perpendicular. So we're going to take our compass again, and we're going to place it on B, the top of our triangle, and we're just going to move it so that it will intersect our side. Okay, and it's going to intersect it down here. Okay, so you can see it intersects here and it intersects over here. Now what I want to do is I want to adjust my compass so that it's larger than half the distance. If I visualize this as half, over here is a little greater. So I'm going to move it, let's say right here. Okay, I'm going to swing it up, and I'm going to do the same thing on this side, keeping it there, and I'm going to mark it. Let's move this over so I can do it without the camera in the way. There we go. Okay, where those two arcs cross, right here, and with this side, I'm going to take my ruler and I'm going to align this intersection with my vertex, and I'm going to draw my altitude. My altitude may or may not bisect side AC. It may or may not bisect my angle. And altitude just means that it is the height of your triangle. Okay? Okay, we have a new theorem called the centroid theorem. It kind of sounds like a weird word. Centroid, it means the medians. So each of these lines bisects the side opposite. And what it says is that the length of your median, it splits it up so that this length right here, JP, is 1/3 the length of the whole line. So here is what we are going to write. AP, this median right here, AP, equals 2/3 AK, the whole thing. BP, this median here from the top of the vertex down to the centroid, this line is 2/3 of the whole line. BL. And our last median right here, CP, that equals 2/3 of median CJ. We are going to use those to find various lengths of the medians of our triangles. So let's turn to example 1. Alright, in example 1, we know that triangle XYZ, P is my centroid. And we know that YV equals 12. This whole line is 12 units. Find YP and PV. Since we know that P is a centroid, we know that YP equals 2/3 of our whole length, which is 12. What is 2/3 of 12? If you said 8, you are correct. Okay, to find PV, I can use some math here and remember that the leftover is 1/3 if the whole length is 12. And I have this part right here that's 8. How much more do I need to get to 12? What I'm asking you to do is 12 minus 8, which is 4. Alright, in example 2, I do not tell you that G is a centroid, but you can tell by my congruent marks that I have all kinds of medians here. So I need to then use deductive reasoning and know that G is a centroid. So if CG, this length right here, is 4, I want to find the length of GE. So I have to ask myself, what part of CG is my length? Is it the 2/3 or is it the 1/3? So if I look at it, hey, it looks like it is 2/3. So if 4 equals 2/3 the length of CE, how can I solve for the whole length? You can multiply by the reciprocal. So how long is CE? Cross cancel. If CE equals 6, this whole side is 6. How long is this little side? I've got 4 already, so I need 2 more. GE is 2. Excellent. Number 3, you will need some graph paper. It tells you that you have an artist designing a sculpture, and it tells you that I have 3 vertices on my triangle. I want to know the coordinates of the point where the artist should place the pole so it will balance. This is how you get those cool toys when you were little and you balanced them on your finger and it looked like it was flying. It uses the math of the centroid. So what I want to find is the centroid of the triangle. So I'm going to take this and let's graph. Okay, here's my graph. Let's draw it out here. Let's plot our points. We've got one vertex at 1, 4. We've got one vertex at 3, 0. And we've got one vertex at 3, 8. Okay. Remember, our centroid is the place where all of our medians meet. So if I want to draw a median, I need to know the distance of each side. For example, CB, it's vertical, so I can count it. It's 8 units tall, so the midpoint would be right here at 3, 4. I'm going to connect it to my vertex A. Okay. Now my side AC, it has a nice slope here of 2. So where's my midpoint of AC? It's right here at 2, 6. I'm going to connect vertex B to this point over here on AC using my ruler. And then I need one more median. I'm going to go from vertex C to side AB. AB is also a slope of 2. So here's its midpoint. And I'm going to connect it. And they all meet right here at that point. That's my centroid. I want to find out where that is. So if I use my graph, I have 1, 2, and if I use my ruler, come down, it's about a third, 2 1/3. And then where's my X? 1, 2, 3, 4. Here's where I want to place the pole to perfectly balance my triangle at the point 2 1/3, 4. So let's write that on example 3. Alright, example 4, last one. Yay! Okay, we have some more vertices. We have triangle HIJ. So let's go ahead and plot our points. H at 1, 2. I is at -3, -3. And J is at -5, 1. Use a ruler to connect your lines. Okay, you have that nice, lovely little triangle. Okay, now here you have a new word, orthocenter. Okay, so what does centroid? Centroid is the place where all your medians meet. Orthocenter, this is the place where all your altitudes meet. Okay, remember, an altitude is perpendicular to the side, so we need to take into account slope. Let's look at HI, the slope of HI. Let's find that. The slope of HI, remember, rise over run, so 1, 2, 3, 4, 5. Over 1, 2, 3, 4. So the altitude is perpendicular. That is going to be -4/5. So if I go -4, 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, that's going to be perpendicular. How can I find my equation or where I'm going to be going? Let's find the equation of our altitude. We want it to go from J. So 1, 2, 3, 4. 1, 2, 3, 4, 5. This point right here. So I'm going to use my ruler. I'm going to connect to the side. There's one altitude. Okay, let's find the slope of IJ. Slope of IJ, rise over run, so 1, 2, 3, 4 over 1, 2. That simplifies to just 2. What would be the perpendicular slope? Remember, it's negative reciprocal, so -1/2. Since I'm finding IJ, I'm going to come across the street over here to H. I'm going to use H as my guideline. -1, 2. This point right here is going to be on that line. So I'm going to take my ruler and connect this point that I drew to H. And connect it all the way to side IJ. There's the second altitude. I need one more. My last side is over here, JH. My slope is 1 over 1, 2, 3, 4, 5, 6. So the perpendicular slope, -6. So if I'm talking about this side, JH, I need to come across the street to letter I. Okay, it says 6. So I'm going to go up 6. 1, 2, 3, 4, 5, 6. And I'm going to go negative 1 right over here. Now I'm going to connect that point with my vertex. Okay, now you should see they all meet right here in the middle of this square. I'm going to zoom the camera down so you can see that. There you go. They all meet right here. I need to know what point that is. So I'm going to go 1, 2, 3. It's negative 3. It's about negative 3.5. And what about my y? My y, it's about negative 1/3. Okay,